Okay, so for the purposes of the video, this is my chromosome, and then if you can imagine it, like this is all it winded and bunched up, and then imagine this as a circle, but since I only need this little portion of it, we're just gonna use this, and it's winded together. So you take your enzyme helicase, which are both part of the replication. You take these helicase enzymes, and they are here unwinding these DNA strands. And since when you unwind it, you don't want it to be all bunchy, this enzyme topoisomerase comes and makes sure it doesn't all bunch at the end. So when you get this, sorry, it's hard to record with one hand. You get this, because of these enzymes, you get this replication bubble, and these two areas here and here are the replication fork. So the next enzyme is your enzyme DNA poly 3. Oh, sorry, actually first you need your RNA primers. So you take this on the leading strand, where this here is the 3' end and this is the 5' end. Since you go 5' to 3', and you need a primer so that you have the OH place to bond to, you put your primer here for the leading strand because you replicate in the 5' to 3' direction, which is easy on the leading strand and pops in your DNA from DNA poly 3. It's a little more complicated for the lagging strand because you can't go in the 5' to 3' direction quite as easy. So you have Okazaki fragments because this is the 3' end and this is the 5' end. And you have to go 5' to 3'. So you need extra primers in these fragments. So here's a primer, here's a primer, and here's a primer. And then because you have those primers and that OH end to bind to, you get little fragments in there. And you go into the 5' to 3' direction, 5' to 3', 5' to 3'. Perfect. And then your next step is DNA poly 1. We'll replace these RNA primers here with DNA sequences. So DNA poly 1 will go through and replace these primers, and you'll have DNA in there. And then once all of it is DNA, you'll have another enzyme called ligase, and it will combine all these fragments. So I'm just going to represent that by taking all of these pieces out, which isn't really what happens. It really just binds them together. But then you show that one solid piece of DNA that is there after ligase comes through.